All right, and we're live. Okay, so this lesson is going to be over segmented bends. And basically, what segmented bends are is whenever you're trying to bend a 90 at a significantly long radius. Uh, our normal benders are built to bend one bend, like get the whole 90 in one bend. But you can also bend a 90 by putting a lot of smaller bends. You could put just just to get the concept, you could bend three 30-degree bends and get a 90. You could bend let's see, three 30s, six 15-degree bends to get a 90. And you can, the more you decrease that number, is 18 5-degree bends. Like the lower the degree, the more bends it takes, but also the smoother the bend will look. Um, so this question right here is about calculating the radius of the bend, because most of this uh, you will be working based off of the radius of the bend. You'll you'll be doing this in situations where you're trying to bend conduit around like a tank or some big wide curved surface, and you'll have to work out the radius. And there is ways to like take a 10-foot piece of unistrut, put it up against the wall and measure from both sides, and there's a formula you can use to work out the radius of that building. Uh, Now, before we really get into this, just like the last lesson we talked about, like we don't really use radius adjustment out in the field. In this one, we don't really do segmented bends that often. There is a time and a place for segmented bends, but it's mostly used in situations where it's uh, words. Like we mostly will kind of rough it in. It's not done exactly right according to the book. What some people will do is they'll take a 2x4, they'll strap down the conduit at one end where they want it, and they'll take the 2x4, which is going to stand a little bit further out than they need the conduit to be, and they will gradually put a little bit of bend as they go around the surface of the tank or whatever they're doing. And that's how they'll do their super long radius bends. That also gives you the benefit of, think of if you had a 90 bent across a 10-foot piece of conduit, like from start to finish it was 190. That would be really, really difficult to spin onto your pipe, like connect to your fitting or whatever, because you'd be having to swing around this long ass piece of pipe. Uh, so screwing on a straight piece of pipe and bending it in place is significantly easier. Okay, so all that said, here is how you would calculate doing segmented bends if this is something you decided to do. If the radius, so first thing you need to figure out is the radius. Uh, they give you the radius to the center of conduit D. And this is an addition problem right here. It's straight up addition. So center of conduit D is 24 inches. And conduit D has a 1.9 inch outside diameter. So start out, basically you're going to Oh, that's nice. So what you're going to do, what we're looking for conduit B. Basically, you just need to get the measurement that is from the center of D to the center of B. That's it. That's all you're doing. So B is 4 inches outside diameter. So to the center of it is 2 inches from the edge. Then you've got the 3.5 inches of conduit C. So that's 2 inches and 3.5 inches. That's 5.5 inches. And then 1.9 inch outside diameter, I'm just going to call that 2. Sure, there's more to it, but I'm going to call it 2. And so we're already halfway across. So we just need the other one. So we're at 6.5 inches. And then there's these gaps, which this says the gaps are 4 inches. We have 2 gaps. So we have 6.5 plus 8. 6.5 plus 8 is 14.5. Yeah, 14.5. So 24 and 14.5 is, it's just under 14.5, but like it's 14.45. Oh, yeah, my nose. Okay. 24 and 14, so that's 38.45. Hey, look, there's 38.45, and that's the answer. And there is a picture of the math. So it's half of the diameter of D, because you got to get from the middle to the outside, then a space, then a 3.5 diameter of C, then a space, then half the diameter of B to get to the center. If you had this built in front of you, all you would need to do is take a tape measure and be like, all right, we're good. But you don't. You have to do it, mathematically. The radius, orange, has its edge 6 inches away from a cylindrical tank with a diameter of 12 feet. If the diameter of the tank is 12 feet, all delete circle. So if the diameter is 12 feet from the center to the edge, is going to be 6 feet, and then its inside edge is 6 inches away, and then we have a 4.5 outside diameter. So then we have another. This is obviously not to scale. So that's 6 feet. Then we got 6 inches, and then to the center of the conduit, let me put a comparatively large conduit. Six feet, got 6 inches. Then half of the conduit is going to be 2.25 inches. So 6 feet, 6 feet, 8.25 inches. Let me look at our answer options. Okay, they're in inches. So we got to pull up a calculator, or I do. Because 6 times 12 to get into inches, 72 plus 8.25, 80.25, 80.25 right here. That's it. That's all you had to do. It's, again, just a measurement. There's no calculation, really. It's just tape measure. If you were able to, like, walk up to this, you develop length. So this one, I would use the book. to determine this one, but I remember this question from when I made the quiz. All of the above. All of these are formulas to determine developed length. I like this top one the most because radius times 1.57 divided by 2. Real simple. Yeah, that's crazy. But radius times 1.57 divided by 2 is a really good developed length for a 45-degree segmented bend. And for a 90, it's just radius times 1.57. This would, this one down here gives, this little section of the formula right here gives you the developed length for a 1-degree bend, and then you multiply it by 45. I believe this also gives you the developed length for a 1-degree bend. 0.0175 times the radius, and then you multiply it by whatever degree you're going to. Let's see. What is the developed length? So let me show you that formula. 37, so your radius, they gave you the radius. This part of the question is useless. Going to 90. You're going to use the developed length formula. You can find it in this conduit bending book. Your book that you're going to want to use. You can look it up in the index, the book. I don't know what page it's on, but I'm sure there's an index that would send you directly to developed length. Well, damn. Developed length is... So, I'm going to look up segmented bends instead. Just give you a page number. It's 140 to 147. Developed length is on page 141. And it was just that easy. And page 142 actually has your formulas in that paragraph, those paragraphs. But if you want the formula for a 90, it's the radius times 1.57. That's all you need. So this one is just 37 times 1.57, which came out to 58.09 was the answer. And that real simple, not a whole lot of steps. That gave you most of the information, and I gave you a formula to use. Write it down right now, or just search it up. All right. Developed length for conduit C is so it looks like that arrow is pointed at the edge of C. So let's look and see. Let's see. I want to look at the explanation, make sure I'm using the right numbers, because this one, I know they've done it kooky before, because it's either 29 or it's like what, 30.75. Okay, yeah, they 29 plus 1/2 of 3.5. So that's to the center of the conduit. That arrow is pointing to the edge, and they added the length to the center, which the outside diameter is 3.5. You add half of the outside diameter, get to your center, and then times 1.57 again. Just get your radius, multiply it by 1.57. That's it. All right. Next up, calculate the shot spacing for the 90-degree bend shown. This is a multi-step problem. There are 15 shots. You have a radius of 32 inches. So first, you're going to find your developed length by 32 times 1.57. So that's 1.57. So that is your developed length right there, 50.24. And there's 15 shots in that developed length. That means from start to finish, it's 50.25 inches long, your developed length. And, I didn't tell you what developed length was. I've been talking about it. So let me back up. What developed length is when you're doing segmented bends, that is the length of pipe you will have to use to get your length, like to get that radius. You have to put bends in the conduit for that length. So from start to finish, that's how far you need to have of conduit. So we have to have 50.25 inches of conduit and 15 shots is the number of shots we decided. Gets us our best look. The number of shots can be completely arbitrary to a point. It's usually best to have an odd number so that there in the middle there is a bend. It just makes it does a weird thing with your eyes whenever there's not a bend in the middle, because there will be a straight spot. But it looks better. Okay, we're going to divide by 15. So we got 3.349. So 3.35 inches between shots. So you'll put a bunch of marks all down your conduit. And with 15 shots, just to go one step further, how many degrees of bend are each shot? We got 15 bends to get to a 90. So you just take your degree and divide it by 15. So each bend will be 6 degrees. Will you measure every single one? No. But you'll measure every couple of them. Like you'll do 2 or 3 and make sure you're like, okay, we're at 18 now. Because you're not going to be able to measure 6. And if you'll just adjust, like, oh, we're a little bit high, so we're going to do a little bit less. You want to be as accurate as possible, but with this small amount of degrees, you're kind of going to be asking too much of yourself. And again, here is the work done. So this is, they found the developed length, they divided it by 15, and got their answer. I'll scroll down there and let it sit for a second. Okay. Every once in a while, I catch myself going a little too fast. Okay, shot spacing, same exact question. I say exact, different numbers. All right, so we have 60 inches times 1.57, 94.2, and we'll divide that by 25. 3.76, got 3.77, and that's the answer. And that's it. That's all the questions. All right, guys. Well, that was right on time, actually. I'm going to put up a review. I will not be doing a video for that review, but you're welcome to watch any of the videos from today over again. The links should work. I think Wazy was saying he was having an issue, but the links should work from the Discord. So, all right. Y'all have a good evening.